This illustration shows two very different cooking environments. On the left, dodging obstacles to move a hot saucepan from a charcoal sagiri makes preparing a meal exhausting and dangerous. On the right, an organized space makes that exact same movement effortless. Physical exhaustion and near accidents in the kitchen are measurable results of poor spatial design. Mastering kitchen layout and tool selection creates a foundation where cooking is fast, safe, and efficient. Before organizing the physical layout, you must evaluate your tools and group them by their function. This diagram maps standard kitchen equipment into functional zones. Watch as items like an omolawo, saucepans, a sagiri, a fridge, and knives sort themselves into their respective categories: measuring, cutting, mixing, cooking, cooling, and cleaning. Formally classifying these tools determines where they belong in the room. This immediately reduces hazards, such as keeping sharp cutting tools far away from a wet washing basin. Selecting equipment for these zones is guided by appropriate technology, choosing tools based on local environmental reliability. This comparison matrix evaluates a high-end electric oven against a locally made charcoal stove. When a home has an unstable power grid, the electric oven fails the reliability test, while the charcoal stove earns a checkmark for being a more practical tool. To be truly appropriate, technology must be affordable, reliable within the local infrastructure, and easy to maintain. A kitchen is only as advanced as its ability to operate flawlessly within its specific environment. Once your equipment is selected, spatial planning focuses on three anchor stations: the cooker, the sink, and the food store. Connecting these three high-traffic zones creates the work triangle. This triangle is designed to minimize walking distance while keeping the hot zone around the cooker clear of cross-traffic. A tight, unobstructed path between these 3 points is the primary metric of a successful kitchen design. The architectural shape of the room dictates how you arrange these stations. We use the acronym PLUS to remember the 4 standard floor plans. In narrow spaces, the P stands for a parallel layout, where stations are split across 2 opposing walls. The L stands for an L-shaped layout using 2 adjacent walls, while the U encloses the cook on 3 sides for maximum efficiency. The S represents the straight-line layout. While it lacks a triangle, it provides a logical linear progression for small, single-room urban living. These architectural boundaries dictate which layout will best protect the integrity of the work triangle. Look at this empty L-shaped room. Mentally place the cooker, sink, and food store along these 2 walls to create the safest work environment. Spacing the sink and cooker on separate walls, with the food store nearby, creates a functional triangle with clear buffer zones between each station. Mapping these zones on paper uncovers layout errors before any equipment is purchased. Logical layouts prevent physical risks, such as placing a cooker directly beside a refrigerator, which creates energy waste and unnecessary heat exposure. Efficient layout must be paired with regular maintenance. This includes drying metal tools to prevent rust and clearing ash from sagiris to maintain airflow. A perfectly planned layout is only effective if the tools inside it are kept in safe working condition. This dashboard connects the functional grouping of tools, the selection of appropriate technology, and the application of a PLUS floor plan. Systematic spatial planning removes physical barriers to movement, creating a safer and more reliable environment for food preparation. Whether boiling water on charcoal or baking with electricity, excellent cooking begins with a systematically engineered kitchen.